Welcome. My name is Doug, and I'm here to teach some calculus today, really basic stuff. What we're learning is the basic introduction to integrals, so we're not going to do anything ridiculous. I really just want to show you the format and how you're supposed to lay it out and what you're supposed to do, so there shouldn't be any brain busters in here today. What is an integral? An integral, also called Riemann integral, the numerical measure of area bounded above by the graph of a given function, below by the x-axis, and on the sides by ordinates drawn at the endpoints of a specified interval. The limit, as the norm of partitions of a given interval approaches 0, of the sum of the products of the function evaluated at a point in each subinterval times the length of the subinterval. Okay, it's a lot of words. A lot of people don't really know how to compute that. Some people do, but I think this is way easier to understand, and I kind of read it myself. An integral is an area between a given curve and the x-axis between endpoints A and B, also as bounds. So if you look at the graph down here, the S is your integral between endpoints or bounds of A and B under the function line and in between above the x-axis. It's kind of like solving for an area. What you need to already know is just basic derivative rules, so power rule, because that's all I really want to do today, and cosine and sine, and the formula for after you take the antiderivative of f of b minus f of a. Alright, so problem 1, you guys can pause the video when the problem comes up and try to work it on paper. These are pretty simple problems, just really to help you get down the format of how to do integrals, or basic integrals I should say. Alright, so the sum of 3, 1, x squared plus 3 dx, you need to recognize your bounds first. So b is equal to 3, a is equal to 1, those are your bounds. And then you have x squared plus 3 dx. So what you want to do is you want to take the antiderivative of x squared plus 3. So if you were to do that, instead of subtracting 1 when you find the derivative of a normal function, you're adding 1. Now adding 1 in this case will give you 3. The 3 is equal to n, number, n. And what you do is you take that, and instead of multiplying the front number x, you divide it. So it's x, 2 plus 1 equals n over 3 plus 3x, which gives you x cubed over 3 plus 3x. Now what you need to do is you need to substitute in your bounds, your 3 and 1. So f of b minus f of a, which would be f of 3 minus f of a. But you need to plug in your functions. So it would look something like this. 3 cubed divided by 3 plus 3 times 3 subtracted by 1 to the third power over 3 plus 3 times 1. You get on the left side is 27 divided by 3 plus 9, and on the right side subtracted by 1 over 3 plus 3. Okay. That will give you 18 minus 3 and 1/3, which is 14 and 2/3. So your answer for x squared plus 3 dx is equal to 14 and 2/3. Pretty basic stuff. We'll do another one to get down the format of the problem. Alright, so problem 2. Your bounds being 4 and 0, 2x plus 4 dx. So recognize your bounds, just like the other one. B equals 4, a equals 0. And then you're going to take the antiderivative of 2x plus 4. So you add 1 instead of subtract, set that equal to n. And then instead of multiplying by n, you divide by n, plus 4x. So it should look like 2x squared over 2 plus 4x. Now since you have 2 divided by 2, you can cancel those out, and you end up with x squared plus 4x, and you can take out an x out of both of those terms, so it's x times x plus 4. F of b equals, or subtract f of a, so just plug those bounds in, and you get 4 times 4 plus 4 minus 0 times 0 plus 4. You get 32 minus 0, and your answer for bounds of 4, 0, 2x plus 4 dx is equal to 32. Pretty simple stuff, guys. Okay, so for this one, you start off and notice that there's no bounds on this one, so you don't even have to worry about f of b minus f of a. You don't have to recognize anything. So you're just taking the antiderivative in this problem, and you're done. So it's real simple. So opposite of sine, if you know your derivatives, is cosine. So what you need to do now is drop down the 2, and then if you have sine as the derivative of a normal function, the normal function has to be negative. So I just slide that in there. So your answer for 2 sine x dx is equal to negative 2 cosine x. Okay. So some common mistakes when starting integrals is just some people forget to take the antiderivatives first, and they go straight to putting in the bounds of a and b, and that can really screw you up because you need the antiderivative. Another thing is just knowing derivative rules when it really gets into higher math. If you don't know chain rule, power rule, or product rule, it can really hurt you because you won't be able to define the antiderivative, because when you do these integrals, you just really think backwards. That's all you have to do. Take backward steps. If you still need help, basically this is a website, www.integrals.wolframalpha.com. It's more of a website to help you on the antiderivative step, because it doesn't let you plug in bounds, and it's not just going to give you a straight answer with bounds and stuff. But it will give you the antiderivative if you need help on that part. So visit that website, even if you don't need to. It's a really nice website. wolframalpha.com is good for math in general. And that's about it today, guys. So thanks for watching. I hope you learned something, even if it's basic steps of how to do integrals. I'll see you around.